Hi students, we are going to begin with Chemistry, Lecture Notes, Chapter 1. This is Section 2. Section 2, Matter and Properties. Under A, volume is the amount of three-dimensional space an object occupies. Under B, mass is the measure of the amount of matter. We use a balance to determine this mass, and it's usually found in the unit grams. C, matter is anything that has mass and takes up space. D, basic building blocks of matter. Number 1, the atom is the smallest unit of an element that maintains the properties of that element. Number 2, an element is a pure substance made of only one kind of atom. Example, carbon, hydrogen, and oxygen. Number 3, a compound is a substance made from atoms of two or more elements that are chemically bonded. Many form molecules, the smallest unit of an element or compound that retains all of the properties of that element or compound. For instance, C6H12O6, CO2, H2O, NaCl, or O2. Under E, properties and changes of matter. Number 1, properties used to distinguish between substances. Properties or characteristics are either physical or chemical properties. Number 2, property may be characteristic that defines an entire group of substances. An example is metals conduct electricity very well. Under F, physical property types. Number 1, extensive properties. These depend on the amount of matter that is present. Example would be volume, mass, and the amount of energy in a substance. Number 2, intensive properties do not depend on the amount of matter present. An inborn characteristic. An example, of course, is melting and boiling points, density, conductivity to electricity or heat, color. Number 3, physical property. These are characteristics that can be observed or measured without changing the identity of the substance. Describes the substance itself rather than describing how it can change. Example, water melts at 0 degrees Celsius, 273 Kelvin, or 32 degrees Fahrenheit, and boils at 100 degrees Celsius, 373 Kelvin, or 215 degrees Fahrenheit. Under G, physical change, a change that does not involve a change in identity of the substance. Example, grinding, cutting, melting, and boiling. Number 1, changes of state, physical change of a substance from one state to another. Number 2, states of matter. A solid has a definite volume and a definite shape. Particles are packed together in relatively fixed positions, held by strong attractive forces. They vibrate about a fixed point. B, liquid, definite volume but an indefinite shape. Particles are close together but can move past one another, move more rapidly than those in a solid, overcome temporary attractive forces between them that allow the liquid to flow. C, gas. Neither a definite volume nor a definite shape. Assume the shape and volume of the container. Particles move very rapidly with great distances from one another compared to liquids or solids. The attractive forces are much weaker. D, plasma, high temperature physical state of matter in which atoms lose their electrons, found in fluorescent bulbs, the sun, or stars. E, melting and freezing involve solid and liquid changes. Boiling and condensation involves liquid and vapor changes. All are simple changes in state, but not turned into different compounds. Distances and interactions have changed. Under H, chemical property, relates substance's ability to undergo changes that transform it into different substances as with reactions. Carbon plus oxygen yields carbon dioxide. Carbon dioxide is a new substance with different properties. Other chemical properties, rusting, tarnishing, burning, or decomposing. Under I, chemical change or chemical reaction, change in which one or more substances are converted into different substances. Number 1, reactants react in a chemical change and products are formed by the chemical change. Under A, the example, combustion or burning. We take carbon plus oxygen yields carbon dioxide. Under B, example, decomposition. We're going to take mercury 2 oxide yields mercury plus oxygen. Number 2, total mass before and after the reaction remains the same. J, energy is always involved when physical and chemical changes occur. Energy forms may include heat or light. Some energy may cause a physical change, such as change in a state, or more energy may cause a chemical change. Physical and chemical changes can be confusing. Under K, law of conservation of energy. Energy can be absorbed or released, but cannot be created or destroyed, only changed in form. Total amount of energy remains the same. L, classification of matter. All matter can be classified into either pure substances or mixtures. Pure substances can be element or compound and does not vary from sample to sample. Number 3, mixtures contain more than one substance and can vary in composition and properties from sample to sample. Number 4, classification of mixtures and pure substances are based on ability to separate. Mixtures are classified based on uniform composition and pure substance is based on decomposition. M, mixtures, the blend of 2 or more kinds of matter, each of which retains its own identity and properties. These are mixed together physically and can usually be separated physically. Composition is listed in terms of percentage by mass or by volume. Number 1, homogeneous mixture of uniform composition, same proportion throughout, called solutions. Example, sugar water, saline solution. Number 2, heterogeneous, mixtures that are not uniform throughout. Example, clay water. Number 3, mixtures can be separated by filtration or vaporized to separate into different components, or decanted or centrifuged, or we can use paper chromatography. And pure substances are homogeneous and have fixed composition and differs from a mixture in the following ways. Number 1, every sample of a given pure substance has exactly the same characteristics, chemical and physical properties. Number 2, every sample of a given pure substance has exactly the same composition. Number 3, pure substances are either compounds, can be decomposed into 2 or more simpler compounds, or elements by chemical changes. Example, water into hydrogen and oxygen by electrolysis, figure 1-10A, or elements, example, sucrose equals carbon, hydrogen, and oxygen, figure 1-10B. O, chemicals in laboratories. Number 1, USP, which stands for United States Pharmacy, grade is purer than CP grade, which is chemical pure, which is purer than technical grades that the industry does use. This concludes Lecture Notes, Chapter 1, Section 2. Thank you very much.